Welcome. Welcome to Presto, You Got It, where we use insightful comments and analysis to make your learning easy, interesting, and fun. In addition, on academyforadvancedstudy.com, at very affordable price, we offer many tutoring programs to help you. We cover SAT, ACT, AP, all the college prep materials. Of course, we cover many K-12 subjects. We even cover college level materials. Again, at very affordable price, we cover advanced topics in statistics, computer science, and data science. We also cover programming and engineering, Python, Java, JavaScript, HTML, CSS. All you need to know in the age of AI. If you want to go to medical school, we can help you too. Again, at very affordable price, we offer tutoring program for MCAT. Now let's go back to our talk today. What we are going to talk today is to continue our conversation last time. Last time we had the concept edition of the lmplot. We examined what it can do. Today we're going to pay closer attention to the coding portion of this talk. So what we have here is a Jupyter notebook. So let's run the code. The first thing we do here, actually let's introduce lmplot a little bit. So what it is a function in the Python Seaborn library. Seaborn in Python, it's a statistical visualization library. They offer many utilities for you to visualize your data and to do your statistical analysis. So the main job of this lmplot is to combine scatter plots, all the data points, individual data points, and regression lines. So regression lines, it can actually do more than linear regression lines. It can do polynomial, and it can also do logistic regression. So let's look at all its functions one by one. First, we need to import libraries. Here we import total 4 libraries. The first one is Seaborn. That's a statistical visualization library in Python. We import it as SNS. Then we import matplotlib, specifically pyplot. We import it as PLT. Then the matplotlib is a data visualization library. Next, we import pandas. Pandas is for data manipulation. We import it as PD. Then we import NumPy. NumPy is for numerical computing. We import it as NP. So with that taken care of, what we will do is to create a fictitious data set. So the data set we are going to create covers hours studied by a student and the exam score he or she received on particular exam. We also introduce a third variable, gender, male or female. So to produce hours data points, we use NumPy's random integer to produce 50 integers. And then we have gender variable. We just randomly choose male or female for each student. Again, the size is 50, and we have scores. So what we do is that we have 40 as a base score, meaning if you do not study at all, you still get 40 points, and that's probably not good enough for you or for your parents. So then for every hour you studied, you get 5 more points. And but the word is never perfect, so we're going to introduce some random. And here we use numpy's random normal to introduce some random variable with a normal distribution. I mean, what we have here is the mean is 0 and the standard deviation is 5. And again, we produce 50 data points. Then with df equals pd.dataframe, pandas data frame, we build the data frame data set. We have 3 columns. Hours studied, the data come from hours. The exam score, the data come from scores we established earlier, a few lines above. Gender, the data come from gender. Then we show the top 5 data points. So we have students studied 7, 4, 8, 5, 7 hours, and they got different score. So that's life. See, the first student studied 7 hours, got 67, and the fifth student actually also studied 5 hours. 5 hours got 78. Life is not fair. Next, we will use lmplot to plot some basic or standard default plot. So let's run the code here. Oops. Voila, we have our plot. So what we have is a standard scatter plot plus a regression line. Behind the scene, we had the separate talk to help you understand how Seaborn compute or draws this regression line. So if you are interested, please take a look at that talk. So what we have here is that x horizontal axis we have our studied, and vertical y-axis we have exam score. Each data point here on the graph represent one student. How many hours studied, how many, what's the score for that particular student, and we have a regression line. So that's a standard default plot. And with this, you actually do not need to do a lot. All you need to do is to supply the data set to the data parameter. What we supply is a df, which is what we produced earlier, df. And then we supply x. We say, okay, we want hour studied as x variable and exam score as a y variable. We can change that later on if we are interested in other aspects of this data set. And then we can set a title. We'll say linear regression, hours versus exam score. And we will, with the show, we will display this plot. Now let's go to the next section. What we do in this section is customizing the plot. So there are many things we can do to make a plot that meet our requirements. The first thing we can do is to say, okay, sometimes we don't want that confidence interval shading, as we have here. We have a little shading to help us understand the confidence interval for any data range. So for any hour studied, we'll have some idea what's the confidence interval for that number of hours. So first, sometimes we don't want that confidence interval, so we want a cleaner plot. So what we do here is to, as we have here as the first line, we will say CI equals none. CI stands for confidence interval. So we're going to say, no, we don't want any confidence interval. So let's run the code. So here we got cleaner plot with no confidence interval. Sometimes you want this. And next, what we can do is to change the line color and the style. So what we have here is that we change the line color to red, and we're going to change the width of the line, and we also change the line style to dash. So let's run the code. So here we have a red dashed line as a regression line, but here we didn't see anything about CI or confidence interval, so we still have a confidence interval shading here. Next, we can add grouping with hue. So it's actually quite useful. So all we do here is to just add hue equals gender. That's why we produce the third variable gender. So we can do some comparison between male and female students. So as we can see here, both gender, we have upper trend, meaning you study more, you got higher score. But for a male student, it seems the number of hours studied matter more. So for female still matters, but not that much, not as much as the for the male student. It's a quite interesting comparison. Next, we can actually produce subplots. So what we do here is to use the column parameter. We'll say, okay, we're going to use gender to produce two subplots. So let's run the code. So here we have side by side two subplots. On the left we have female students. On the right we have male students. So it's actually not that easy to tell which line is steeper. So sometimes we actually want to plot these two lines together because here we have a different color for different gender data points. So all the male gender points we have one color, or the female gender female data points will have a different color. So, but still, sometimes you want to separate subplot. If you want to do that, that's how you do it. Actually, quite simple to do. Next, we can fit the polynomial regression. Sometimes the data, the real life is not that perfect, so we have to do more than linear regression. The way to do it to specify order. Here we say order equals 2, which will give us quadratic regression. So here we no longer have a line, we have a quadratic polynomial regression. Next, we can do logistic regression. It's quite interesting. Sometimes we only interested in the binary outcome. So the way for us to do that is to introduce a new column that's pass. So we'll see whenever exam score is greater than 70, we'll set it as a pass. And we'll set appropriate value in the pass column. So let's run the code here. It is very interesting. All we need to do is to set the y variable set pass column as a y variable, and set logistic parameter to true. So here we have a very nice logistic regression line. Essentially, what it shows is that you have to study at least 5 hours in order to have any chance to pass the exam. It's quite interesting. Now, here we have a summary of all the key parameters of a lmplot. So we have x, y for variable, and the data is a data frame we use for the entire analysis. And hue, we can use that to group categories, male and female student. Column row, we can produce a subplot. And the CI confidence interval, we can specify the size of the confidence interval or none, no confidence interval shading at all. With order, we can do polynomial regression, so no longer confined to linear regression. Order equals 2 give you quadratic regression. Logistic, with this parameter, we can fit logistic regression. Sometimes when we are interested in binary outcomes. Line, KWS. KWS stands for keyword arguments. So this is the dictionary we're going to pass to matplotlib. So with this, we can style the line. So that's what the line means here. We can also do the same thing for data points. So with that, we're going to have scatter KWS. And this is a dictionary we can pass to matplotlib to style the data points. So here we have a final summary. Conclusion, the lmplot function in Seaborn is a powerful and flexible tool for regression visualization. It helps you see overall trends, difference across groups, and confidence intervals. So master the lmplot. It will make your exploratory data analysis much more visual and interpretable. Your boss will like it, your client will like it, your teacher will like it. Alright, that's all we have. Remember, on academyforadvancedstudy.com and academyforadvancedstudy@gmail.com, we offer at very affordable price many tutoring programs to help you. That's all we have today. Thank you. Have a great day.